All righty, here we are. Cormac, how you doing today?
Good, Anders. How are you?
I'm doing well. I'm excited. You want to know why I'm excited? I'm excited because Explorer is coming up, and we are just about there. I think we're at what 13 days now until Explorer begins in US, and 82 until Barcelona. So been a lot of hard
Mm,
work going into there. Are you going this
absolutely.
year?
I'll hopefully be going to Barcelona. I'm not traveling out to the US this time.
Oh,
I'm based in
fantastic!
Ireland, so you know, long haul flights
It's
and all
it's
of
a
that.
quick
Yeah,
jump for you for sure.
yeah.
Easy, easy. Yeah, well, it's going to be exciting in any case. So we got a lot going on. So looking real good here. Let's actually talk real quick about what we've got coming up. Um, so I'm going to go ahead and hide everyone and take a look at what's going on. So coming up right now, in fact, we are here to talk about VCF Data Services Manager for practitioners. Cormac Hogan's here with us today presenting, and we've got Michael Gandy and Kim Delgado are going to be helping with Q&A. So they're actually in the background, so please feel free to ask questions. Um, uh, we are here to answer your questions. We're here to help you with your technical knowledge. So don't be shy. Hop right on in. Speaking of Explore, August 26th, right around the corner, 26th through 29th, Barcelona, November 4th through 7th. The content catalog and schedule builder is open for Las Vegas right now, so you can go ahead and register for your sessions. We've got a lot of fantastic sessions coming up this year, some really, really good. We focused on technical deep dive content. There is actually a lot more level 300 technical content than there has been in years past. So you can actually register, hop in and build your schedule and get locked in for sessions already. For Barcelona, the content catalog went live yesterday. So you can get a kind of a sneak peek of what's going on, but the schedule builder won't be up until the 26th of August. You're going to blink and it's going to be here. So definitely if you're planning on going to Europe, hop in and get your sneak peek. Now this series will be paused over the course of the next couple weeks for Explore so everyone can get ready. We're prepping our content to actually be live in Las Vegas. So we will actually resume again on September 4th. We're bringing back VMware Explorer 2024 recap. Latest VMware Cloud Foundation announcements with Pete Fletcher and Rick Walsworth. I don't know if any of you have had the pleasure of meeting Pete or Rick before, but they're super, super high energy folks. And the probably best possible choice for doing that recap. And we'll go over a lot of the announcements that happened, talk about a lot of high points of the event, and that's definitely going to be a not to miss session. And then coming up on 9/11, enhancing your business agility and accelerating time to value with managed VCF services. So definitely be on the lookout for that as well. So that's about it for me. At this point, Cormac, I'm going to go ahead and turn it over to you. So why don't you give us a quick introduction and take it away.
Sure, sure. Hi, everyone. So my name is Cormac Hogan. I've been with VMware since 2005, I think. So however long that is, 19 years, I guess. Lots of different roles, but to cut to the chase, last year or so, I've been working predominantly on Data Services Manager. So I'm delighted to be able to give you a technical overview of Data Services Manager today. So let's start with why did VMware get into data services management? And it's basically, if you look at these three different teams of IT people, it's to try and reduce the friction between these teams. Now, we've been doing a data services manager product for a number of years, but we did spend a lot of time re-architecting it last year. We launched a 2.0 version just at the beginning of this year, and front and center of that re-architected data services manager was our VI admin or our infrastructure admin. So essentially, data services manager is all about providing data services or databases as a service on premises on your vSphere infrastructure and try to give the apps teams that cloud-like experience. However, to be able to do that, it's not like we have a infinite amount of resources available on-prem. The amount of resources we have available on-prem are finite. And so we wanted to prevent this situation where an app team who is maybe expecting to be able to press a button and get a new database, get a new data service each and every time with no thought given to cost or no thought given to how much resources they're using. We definitely wanted to prevent that. So what we've done is we've given the infrastructure admin or the VI admin the ability to put guardrails around the vSphere resources. And what that means is that the app team can certainly go and press a button and get a database provisioned as they require, but in the knowledge that they are guardrailed around a certain amount of resources so that they can't, you know, uh, consume all the resources on an ESXi host or, flood a network with the amount of databases that they're provisioning or whatever that the case may be. So definitely we had the infrastructure admin or the VI admin front and center, but we still wanted to give the app team this cloud-like experience where they click a button or through a simple API call, they can get a database or data service provisioned on-prem on your vSphere infrastructure. Now, I mentioned friction, and we've heard from a lot of customers that there is a lot of friction between the app team and the data team in trying to get databases provisioned. And so usually, something like a ticket needs to be opened by the app team. That ticket ends up with whoever is responsible for provisioning databases. And usually provisioning a database for an end user type developer is low on the priority list. The data team are doing lots of other stuff for production databases and so on. So this is where the friction arises. So we thought that if we could provide this database as a service type offering for these app teams, which kind of freed up the data team from having to do the mundane tasks of provisioning databases, but also in the knowledge that we've guardrailed the vSphere resources through tools that we give to the VI admin, then we think we have a very compelling product for on-prem database as a service. So that is the big picture. That's our kind of overall view of where we think the Data Services Manager product fits in. And so with that, let's get into the technical side of things and the practitioner side of things. So how does it all work? So we have our VCF or vSphere environment that I try to draw it here. Hopefully that makes sense. We have our ESXi hosts, we have our vCenter server, we have some storage, and what I haven't shown here is just some networking. Essentially what we do is we provide a plugin to your vCenter server. And so you go to, at the VI admin, we go to their vSphere client, they would install this plugin. And what that does then is it rolls out an appliance or Data Services Manager appliance. It's just a virtual machine. And that extends the vSphere client to give the VI admin additional functionality, additional features around data service management. And what they have the ability to do then is build this thing called an infrastructure policy, which is something that we've introduced with Data Services Manager, but this is how we achieve the guardrails. This is how we set aside a set of vSphere resources that can be consumed by the users of Data Services Manager as they provision databases and data services. So the infrastructure policy we'll go into in a bit more detail, but you can think of it as a grouping of compute, storage, networking, and within that grouping, that's the boundary of which the consumers of data services can provision their data services. So with that in mind, the data team then might still be responsible for provisioning databases. So it could be that you still implement some sort of ticketing-based system so that an end user who wants a database will send you a ticket to the data team. The data team then comes along, provisions the database, and what they end up getting is a connection string, and that connection string can then be passed off to the app team to connect to the database. So a little bit about what's going on in the background. What we do is we stand up a Kubernetes cluster as part of the database offering. So it's a VM or one or more VMs that we stand up to host the database, and those VMs create a cluster, which is a Kubernetes cluster, to offer this database to the end users. Now, this is all managed by VMware. We don't expect you to stand up Kubernetes. We actually don't expect you to be doing anything with this Kubernetes cluster. We, as you'll see as I go through the presentation, we take care of the management of that cluster. We take care of the life cycle of that cluster, the updates, everything to do with that Kubernetes cluster. So for all intents and purposes, that becomes a black box. At the end of the day, all you're worried about is getting your database provisioned, and that's how underneath the covers we are provisioning that database. So I said this is just one approach, that there's still maybe some sort of ticketing system that goes to the data team. But we talk about another option next, which is a sort of self-service option. So again, the infrastructure admin will create the guardrails through the infrastructure policy, but in this case, the data team may not have to be involved. It may be that you do want to offer this as a service, as a self-service to the end users. So the app team themselves can come along, and depending on the privileges that you give them, they could have access to the data services manager through a UI or portal that we provide, or an API. And either way, they have the ability to provision their own databases. So that's just another approach. If the ticketing mechanism is causing too much friction within your infrastructure, maybe you're able to give them the self-service approach. But again, in the knowledge that any databases or data services that they're provisioning are guardrailed by this infrastructure policy mechanism that the VI admin controls. Okay, so let's talk a little bit about what data services that we do offer. To date, we have three. We offer PostgreSQL, we offer MySQL, and we have a tech preview of Google's AlloyDB Omni, which is essentially the on-premises version of Google's AlloyDB. So with PostgreSQL, we will offer four flavors of that. In fact, for Postgres and MySQL, we'll offer four versions of each of those. And as we expand, as we release new versions of those databases, then the oldest one will be dropped off the end. You can provision these as single VM, single node databases or standalone databases, or we can cluster them. So we support 3-node Postgres and 3-node MySQL as well. And with PostgreSQL, very important point here is that we ship with a bunch of extensions, one of which is the PG vector extension, and that is the fundamental building block for the RAG approach. If you're familiar with the private AI foundation product that we have, I never remember the retrieval augmented generator, I think it's called, but it's essentially where your AI or ML solution is able to query some of the latest information out of a database. And our private AI foundation solution uses Data Services Manager with PostgreSQL with the PG vector installed. Now, again, on the AlloyDB Omni part of it, as I said, it's from Google and the support comes from Google, but it is only in tech preview and there is only standalone mechanism here. There's no clustering mechanisms, but they do have some novel mechanisms built into AlloyDB Omni as well. So if you're interested or you are a customer of that, come and talk to us too. But to be honest, the PostgreSQL and the MySQL are the two that we see most interested in from customers today. So I suppose this is a good point, Anders. We do have one survey question that we'd like to share with you. So our poll question is, obviously we're just, we only have a handful of data services today, but we're looking to extend that going forward. So what we'd like to share with you is a poll to see what data services you are interested in going forward.
All right, we are up and rolling
So
here.
if you just take a moment, let us. Thank you, Anders. That's great.
Absolutely. Are we betting on these like the horses here? Any predictions for the outcome?
I suspect SQL Server will be there. It comes up a lot. Even though our focus today is sort of open source databases, we do have a lot of SQL Server deployments within our customer environments. So
Definitely how it's shaken out. All right, we'll give about another 20 seconds here. Thank you to everyone for participating. Looks like we've almost got 100% participation already. People were interested in this one. Yeah,
super.
looking good. 57. All right. 10 more seconds. All righty, I think we're looking good here. Let's take a look.
Yeah, that's great.
Yeah, so sure enough, 47% MongoDB, 17% of Redis Valky, 23% RabbitMQ, 77 on SQL SQL Server. Definitely saw that one coming. And then SQL Server Day
Mm.
2 LCM got 60% there. So that's looking pretty good.
Yeah, it's excellent. Thank you, everyone. It's going to help us to sort of figure out, where to go with the next set of data services that we offer. As I said, we launched in January. We wanted to go deep on Postgres and MySQL, get them working extremely well, and then start going wide with some of the other offerings that we have. So super. Thanks for that. Okay. So with that in mind, again, this is just a recap on the sort of the introduction that we went through already, but it's really about offering this cloud-like experience. Click a button, make a single API call, and then just stand up, have a database stood up for you. Now, I will be delving into some of the features that we're offering with DSM. It's not just the day zero provisioning that we're offering, but you'll see things like the automated backup mechanism that we have built in. So as you provision a database, you're not worrying about standing up something to back it up. It'll be automatically backed up, and also the automatic lifecycle management part of it as well. Because what we'll be doing going forward is we will be offering these updates to Postgres, to MySQL, and to any of the other data services that we decide to support. And that can be automatically taken care of as well across your whole fleet of databases. So it just means you're standardized on a particular version of Postgres if you so wish to be. And then we will be providing these patches for you. Um, and again, sort of getting ahead of myself, but what you will see is that you can patch immediately when we release one, but we can also set up an automated mechanism where maybe sometime on a Saturday night when nobody is using the databases, we will roll out the patching as well at that point. Okay, so let's keep going. So again, I do want to touch on the VI admin part again, because we did have the VI admin front and center as part of this re-architecture of Data Services Manager last year. And this is essentially the infrastructure policy. I'll highlight it to you here, but we'll see a demo very shortly as well. So the idea is that you'll pick some compute resources, whether that's a cluster, whether it's a resource pool, entirely up to you. And you'll then select a folder as well where you're going to place these virtual machines that are being created to back the data service. You'll pick a storage policy. We support any of the storages. What I'm showing you here is a vSAN storage policy, just because that's what I had in my lab when I built this out. But you could absolutely use storage policies that are tag-based storage policies and just tag your VMFS or NFS data stores that way, and then just consume the storage policy for VMFS, NFS, vSAN, vVols, whatever the case may be. Next thing is the networking. This is the network where we're going to plumb the data services up onto. It does need to be a distributed port group. So it could be a vSphere distributed switch. It could be NSX, whichever you wish to use. And the last but not least is that usually when you give a pool of resources to some of our end users, they'll always try and build the biggest thing possible. Even though they may not need it. So they'll build these monster VMs for absolutely no reason. What you as a VI admin in this case can do is within the infrastructure policy, you can carve out what we call virtual machine classes. So we do ship with VM sizes, some t-shirt sizes, but you could absolutely go and build your own t-shirt sizes. And the end consumer of the data services, when they request a data service to be provisioned, they're limited to that VM size that you as a VI admin have decided on. Okay. The other part of this as well is the role-based access and LDAP integration. So I mentioned that end users and the data admins, they could log on to your DSM UI. They could access the DSM API. What we do is we control who has access. And this is done through creating either local users or integrating with LDAP. You have those two options. So depending on whatever mechanism you wish to use, you could just create a handful of local users and have done with it, and they're the only ones who can use DSM, or you could integrate with LDAP and provide a whole bunch of users access through an LDAP group whatever the case may be. But we do have these two different roles. We have the admin role, can pretty much do everything. And this is everything from configuring the data services manager, configuring the backup locations, configuring the lifecycle management, Windows, all of that good stuff is done by the admin. Is also the person who could enable or disable different versions of databases depending on what they wanted their end users to consume. And then, of course, you have the end user view, which is just basically CRUD operations, create, read, update, delete type of things. But we do offer these two different roles. And so if you did want to provide your end users to have this database as a service offering or DB as a service offering, you could absolutely just give them user access to be able to do that. Great. So let's have a look at our first demo. This is just basically installing the plugin into the vCenter through the vSphere client. You can see it's installed there. And then if we go and have a look at the inventory and look at the vCenter, you can see that there's a data services manager section that has been added by installing the plugin. And so there's a lot of blurb that talks you through creating your infrastructure policy, but let's go ahead and do that. Now I've done this at a bunch of vmugs, which is why you're seeing that name there. And now we're on to selecting resources. Like I said, you could do resource pools as well if you so wished, but you could also just select a full cluster. But again, it's just limiting to a certain amount of compute resource. Where can we provision to? Now it's on to the storage policy. And like I said, I'm using vSAN, but you could use any of the supported vSphere storages. Where are we going to plumb the data services up onto? There's a distributed port group there. And what we do then is we build an IP pool, which is essentially a range of IP addresses. So again, you have full control over the networking. You're selecting the port group, you're selecting the range of IP addresses that can be consumed. So again, you can, on a end user basis, say you're only going to have 60 IP addresses on my segment, and that's it. You can create as many databases as reaches that limit. And then the last thing, of course, is the VM class. I mentioned this. We have some t-shirt sizes there, but you could absolutely build your own. And then you can decide which of these VM classes you're going to make available to your end users. So in this case, I might say, okay, you can have mediums, and I'm going to be generous and give them extra larges as well. But again, full control over this. And that's my policy created. It's as simple as that. So all of the things I created, like the IP pools, the VM classes, are available there. My last thing to do is create a user. So we have to give a user, we need to have at least one admin user to complete the configuration of DSM. So I'm just going to build one there. You give it a password. Yeah, and there we go. But as I said, you could have LDAP configured as well. We support LDAP integration, and you could also build an LDAP group. So let's go and access our portal. Let's log in as that user I just created. And yeah, there's a few things that still need to be done, as I said, like backups and database images and that kind of thing. But hopefully you get the idea that it's putting these guardrails in place. It's making sure that a VI admin who is responsible for all of the on-prem vSphere infrastructure is not going to get a call out in the middle of the night because some end user or developer created a 1,000 databases with some script and is done something really weird to your vSphere infrastructure environment. That's what those infrastructure policies are all about, putting guardrails around that infrastructure so you don't get those type of situations. All right, so we have the infrastructure policy built. It's now time to build a database. And as I said, we have multiple different approaches here. It could be that it's still based on some sort of ticketing system where it goes up to whoever is responsible for provisioning databases. And there are definitely benefits to using DSM for those type of users, but we could also have the end users do their own self-service as well. So this is an example of what goes into a database creation. So you can see the type of stuff here. In this particular case, the user is going to build a Postgres database. They're selecting a version, they're giving it a name, they're selecting the topology. In this case, it's single server, but I mentioned it could be replicated as well. So a 3-node database. We give the database a name, and we also provide a default user for the database as well, just so you can log in and manage that database. So all of that is populated. Then it comes to the infrastructure policy part. So this is the follow-on from the VI admin. So when a database is being provisioned, the guardrails are in place through the infrastructure policy. So this database is going to be built on the resources that are defined within this infrastructure policy. So you can see things like if there's multiple storage policies, you could select different storage policies. If there's multiple VM classes, you could build or select different VM classes as well. So all of that can be populated. We provide automated backups. So the moment the database has been provisioned, we will start doing backups. So we'll take full backups of Postgres databases once a week. We will do daily backups, incremental backups daily. And also we ship the write ahead logs, I believe it is every time they reach 16 megs in size, or every 5 minutes, I believe, whichever comes first. So all of that, what that means by shipping these write ahead logs is that you can do point in time recovery or restores of that database. And last but not least, there's a database advanced settings or database options. So things like max users and turning on various features of the database. Pretty much anything that is supported in the open source Postgres database can be configured here as well. So that's essentially it. And we'll see a demo of how to do that in just a moment, but hopefully that makes sense. A little bit more on what we think are really neat features of DSM is the automated backup feature. So we do require an S3 bucket, whether that's on-prem, whether it's AWS, in the cloud, whatever the case may be. As long as you have access to an S3 bucket, we will ship those backups to that S3 bucket. And as I said, we do weekly, incremental daily, and the write-ahead logs are also shipped out. The other thing we have is the maintenance window, and this is the automated lifecycle management feature that we have. So let's say that on a Thursday, VMware has pushed out a new update for DSM. So you can download that update, but you don't need to apply it straight away. If you have the update downloaded and available to DSM, we will, as it says there, a minute before midnight on Saturdays, we will apply that patch across your fleet of databases. So there's lots of controls around this. Again, you could manually apply it. You could wait for the maintenance window to kick in to automatically apply it, or you can have the database opt out of automated updates as well. But it just means that you're not going around to each and every database that you have provisioned and doing an update on it. We'll take care of managing the whole fleet from a lifecycle management perspective. So I think those two things are very key. They're things that a data admin or a DBA doesn't have to worry about. If they use DSM to provision their open source databases, we'll automatically have backups kicked in. We'll automatically take care of the lifecycle management. Great. So our second demo, and this one is just a creation of a database. So this is back in the DSM UI, and we've completed the configuration, and now I'm going to go ahead and roll out a new Postgres database. So I'm selecting version 15 and giving it a name again, good old VMware name. I can decide now whether I want to do single server or whether I want to do a replicated database or a clustered database for availability. You can see the different options there. And you can see the database name is the same as the instance name, and the admin user by default is that. So I only had one infrastructure policy created, which is why it's automatically been selected there. I only had a single storage policy, which is why that was selected, but I could select a VM class. And now backups are enabled by default. You can turn off backups if you wish, and the maintenance window is also defined by default. And the last thing you might want to do is add some options. As I said, you could do any number of things here. There are various options you could do with every database. I'm not going to add any in this case. And there we go. There's our summary of the database. And within a few minutes, but I'll speed things along for the purposes of the demo, the database is created. And so there's various labels. You can see the replication. What's even more interesting is you see the roles associated to the database nodes and the VMs that they're using. We have metrics that we capture as well. And last but not least, we have the connection string. And this might be the thing that you hand off to your end user to say, I've built you your database. Here's the connection string. Go nuts on the database there. But alternatively, we could let the end user do this for themselves if they wanted to do self-service. Okay, so that is the database creation aspect. Let's talk about a bit more detail about some of the things I mentioned, like the updating, the monitoring, and the alerting. I said a few times now that our VI admin was front and center of what we were doing with this re-architecting of DSM 2.0. So all of the information about the databases are also visible in the vSphere client. So here, any databases that have been built by DSM, obviously they'll appear as VMs in your vSphere client, but now there are additional views so that you can actually see which databases map to which VMs, what role do they play, and actually you can get in and say, well, who actually provisioned this database? Who's the owner of this database? Because if you see that there's databases provisioned and they're just sitting there idle, not doing anything, and maybe the end user provisioned it and then forgot about it, you can go and look up that detail through the vSphere client and go, hey, are you still using this or can I clean it up and free up some resources? So all of that is visible in the vSphere client. You don't need to log into the DSM UI to get that level of detail. Like I said, you can break out the databases as well. You can see the virtual machine names, what role, are they a primary, are they a replica, and then the amount of resources that they're consuming as well from the allocated resources given to the VM. So again, this is vSphere client side stuff. The lifecycle management, once you get an update from VMware, you'll see the upgrade status for each of the databases change. So this is an indication that there's a patch available for the database. Now, you can go ahead, go straight into that database, and you can say, okay, this is a pretty critical patch for my database. I read the release notes. I know what this is about. I think I need to roll this out straight away. So I'm going to upgrade it immediately. However, because you have a maintenance window also created, if you leave it for the weekend, we will roll the patch out across your fleet of databases. So I think that's pretty neat. Again, you can opt to take the databases out of maintenance windows if you so wish, and that means the patch would not get applied. But if you feel that it's, this patch is kosher, I actually need it to be rolled out. It's a, critical patch, security patch, whatever the case may be, you can just leave it to DSM to take care of that upgrade for you. And actually the appliance itself can be upgraded too. So we do provide updates to the provider appliance, that VM that we rolled out initially. Again, we have the same type of approach. You can install it straight away, or you can wait for the maintenance window associated with the provider, and we'll go ahead and update that as well. So similar to how the databases work, there's a maintenance window for the appliance as well. And the main thing, just to get the point across, is that we can update the appliance without having any impact on the databases. In other words, the control plane, which is the appliance here, can be upgraded without any impact to the data plane or the data services and databases that are running. So just some further information then as well about monitoring, alerting, and troubleshooting. Again, what I'm showing you here is the DSM UI, but what we're doing now is we're also bubbling this up into the vSphere client. And the reason for that is I think the DBAs or the data admins will be able to have a good one-to-one relationship or one-to-one conversation with the vSphere administrator. So something that is seen maybe in the DSM UI should also be seen in the vSphere client, and then an intelligent conversation between the data admins and the VI admins might reveal where the issue lies if something is amiss. Again, we try to provide some additional information about what's going on. I mean, the reason for the warning, and we do try to give you some kind of hints in here as well about what the problem might be. We do have some plans to include this in the whole Ask VMware thing, which links us to knowledge base articles going forward. We actually don't have it just yet, but we do plan to have something like that going forward as well. Great. And last but not least, we kind of saw some of this in the demo. We do have a whole, I wouldn't say we have a complete set of metrics, but we do have some comprehensive metrics to do with databases themselves, which we think would be of benefit to a data admin. So it's not everything, but it's a kind of nice high level view of how the database is performing. Now, having said that, we're going to talk about some other integrations going forward, which will give you even more detailed metrics. And that's integration with the ARIA suite of products. So let's begin with ARIA operations. Like I said, we have some built-in metrics, but actually what ARIA operations has now is some new integrations for both Postgres and MySQL. And the nice thing is all of this is included with VCF. So you get DSM with VCF, you get the ARIA suite with VCF as well, including the integrations. So you can just add the integrations here, pointed at your Postgres or MySQL databases, and then you just start to see some really nice metrics. And what they've actually done with the latest releases of these integrations that coincide with VCF 5.2 is they have built the metrics around personas. So there's like an infrastructure persona that sees infrastructure stuff from the VM and the ESXi and the storage perspective, but there's also a database admin view as well, or a DBA persona view, where you get a view of the database and what's happening inside the database. They did a really good job on this, actually. Really quite nice. So that provides you with deep level metrics, unlike what we have a high level overview within the DSM UI, but to go deep, we have this integration with ARIA operations. On a similar vein, ARIA operations for logs, formerly Log Insight, integration there as well. So again, you just pointed at your Log Insight, your ARIA operations for log server, all of the logs start flowing. And this is not just the appliance logs, but it's also logs from the databases as well. And then you can go and build some really nice dashboards. And me, as a novice user of ARIA operations for logs, I was able to build these very quickly. But we do have a plan to, and I'll probably get the name wrong, or the content packs or management packs or whatever they're called. I think we're going to look at doing those going forward so that you don't even have to build these dashboards for yourself. So this is ARIA operations for logs, but you can, if you're using any other third-party, Splunk or Elastic or whatever the case may be, you can ship the logs to those as well, as long as they support syslog. And we can ship them over TCP, UDP, or SSL now in the latest release of DSM. Now, this is pretty cool as well, because this is when we start talking about databases as a service, typically a lot of customers are using ARIA automation to provide services to their end users. And what we've done is we've built a custom resource for Data Services Manager to plug into ARIA automation as well. So that if you are using ARIA automation to provide these services, you should now be able to provide database as a service very simply using the custom resource that we're providing. So it's just downloading the custom resource or the code from our support portal. You can see we have a README on all the steps you need to do. We have the manifest, we have the code. It's all there for you to look at and examine, and maybe even tweak if you wanted to do things slightly different for yourselves. But all the instructions on how to do this are there. The only thing you really do is you populate a config file to point at the DSM server and the ARIA automation server. So as long as you fill in those two pieces of information, you just run the Python script and bada bing, bada bong, you end up with, in your catalog, a new DSM database as a service entry. And from there, you can request the creation of a database. And for all intents and purposes, this looks exactly now like what we saw when we rolled it out from the DSM UI. But the nice thing is you can customize it. So maybe there are certain teams that only use Postgres and should only use a certain version of Postgres. You can, modify this, fine tune this catalog item to only display those items for you. Similarly, if it's part of a pipeline that it's going to be created, used for some testing, and then discarded again, well, a whole bunch of features like the lifecycle management, the automated backups, that kind of thing, you could turn all of those off by default and not allow them to be tunable or configurable by the end user. So there's various things you can do with this. Not an ARIA automation expert by any stretch of the imagination. I'm sure there's people on this call who are more familiar with it than I ever will be, but hopefully you're getting the idea of how powerful this is as well. So let's have a very quick demo of that ARIA automation in, let's say live, or even though it's not live. But again, as I said, the README tells you exactly what you need to do. You have this config.json file. You can go ahead, fill it all in with the information that's needed. As I said, it's just DSM information and ARIA automation information. And once all that is done, it's just running a Python script. So we have a requirements that's a file that tells you these are the Python libraries that we need. So you can just very quickly install those. There's a pip3 command here to install those requirements, like so, and it's done. Looks like it was already satisfied. And then we just run the install script. So it does put out quite a bit of output. I'll speed things along now as well. But essentially, it's basically all of the components that we're building out within ARIA automation. And here we go into ARIA automation. You can see the new project that we created. You can see templates, actions, and secrets associated with it. There's our template. Good. So open to, I think, what else is in there? The secrets. So this is just to access the DSM, all in there. And so there are two actions, a day two operation, which is basically retrieving connection strings, and the CRUD operation, which just create, update, delete type operations. So we're going to build out a request. I'm going to give it a name. It's Postgres. I'm going to select a version. We're not going to replicate it, I don't think. We can give it a database a name. We just put a default one in there. You can give it your own. Admin user, default one once again. You can give it your own. And in this particular case, there are different storage policies or different infrastructure policies, I beg your pardon, and you can pick whichever one of those you wish. You can see the backup location is enabled and maintenance window is enabled as well. And again, off it goes, rolling out a new database. And while that's rolling out, we can actually request the second one. And this time, I might change things around and do a MySQL. So pretty much anything you can do from the DSM UI, we can do through this custom resource that we built for ARIA automation as well. And as I said, we're just providing it as is. You could absolutely go and fine tune this to meet your own requirements. So 2 requests rolling out, speed things along, have a look at the DSM UI. We can see that their databases are in progress there as well. Speed things along even more because I don't want to keep you hanging around looking at a screen. Back to ARIA automation, and there we go. Our 2 databases have been provisioned. And like I said, there was a day 2 action, which just is getting the connection string. You can see it there. And again, your end user can now use that connection string and connect to the database like we saw before. There we go. So what else can we do? So there are other actions as well. Like the day 2 operations could involve, in this particular case, maybe I need to expand the size of the disk. So I'm going to grow the disk. Instead of 60 gig, I'll give it 80 gig and just commit that. And again, that will go back and you can see the task has been initiated. See it underway. Again, speed it along. There we go. It looks like it's finished. Back to my DSM UI. And even though it's not completely finished there yet, you can see that the storage has grown from 60 to 80. So there we go. So basically, in a nutshell, anything that we could do from the DSM UI, we can pretty much do the same from ARIA automation as well. Alrighty. Now, I guess we're coming to pretty much the final topic. I mentioned that what we wanted to do is give the end users or your app developers or whoever is using these databases a sort of cloud-like experience. And what we mean by that is that they should be able to click a button, provision a database, or make an API call and provision a database. So we've seen plenty of different ways of clicking a button, whether it's through the DSM UI, whether it's through ARIA automation. What I wanted to show you now is the API approach. And because it's using Kubernetes, we'll be using the Kubernetes API server that's built into DSM to do this. So core to all of this, you can see there in the middle, sort of flashing a little bit, is that we have Kubernetes. And this is providing our DSM API server. So what we could do with Kubernetes is very simply create what's called a YAML manifest, yet another markup language, where we describe exactly the database that we want to lay out. And again, it's the usual stuff. It's what database engine, what version of the engine, what topology, is it standalone or replicated? Am I going to do automated backups? Am I going to do automated lifecycle management? All of that stuff just goes into a YAML manifest, and then we just kubectl, if you're familiar with Kubernetes, you use the kubectl to send that request to our API server, and that's it. A database gets provisioned. But there's another slightly different approach to this. What if you have Kubernetes? Your developers are using Kubernetes, but those Kubernetes distributions are not running on top of vSphere. It could be on bare metal. It could be on vSphere, of course, but it could be bare metal as well. What if those Kubernetes clusters are maybe resource constrained in some way? And that you're using them to develop applications, but you don't really have the persistent storage available on them to build out databases, or you don't have the compute power on that Kubernetes cluster to build out databases. Well, this is another way that DSM could help you, because we have this notion of a consumption operator, which simply means that remote Kubernetes clusters, whether they're third party, whether they're bare metal, indeed it could be Tanzu as well, they can install this operator and consume databases through DSM. So what happens is we install the consumption operator component onto the remote Kubernetes cluster that your developers are using. We have this notion of a binding namespace, which says that only these users of this Kubernetes cluster can consume DSM or databases. So your app user comes along, your end user, your app developer comes along, builds out the YAML manifest to request a database, sends that to his local Kubernetes cluster. It's picked up by the consumption operator, which then redirects it all the way over to your DSM, where, guess what? We have infrastructure policies for guardrailing resources. We have all of that stuff, good stuff in place. We have automated backups if necessary. We have the lifecycle management of the database if necessary. You have the VI admin getting a fleet view through the vSphere client of how his resources are being consumed by these databases. And all we need to give back to the app team is the connection string. And they can retrieve that as well through a kubectl command. So they don't interact with vSphere environment, they don't interact with DSM, other than, please create a database for me, please give me the connection string so I can use that database. So I think that's another interesting use case outside of what we talked about earlier in the presentation. So one last demo. This one is just to show you a YAML manifest and how we would build a database using a Kubernetes API server or the DSM API server. So we provide you with the kube config, which is nothing more than how do I access the API server. There's two different ones. There's one for the vSphere client, so actually you could build infrastructure policies with YAML manifest as well if you so wish, but we're actually more interested in building out the databases. So let's have a look. So we have a database already existing. let's go and build another one through YAML and the API server. So I'm just moving these around a little bit just because we have two API, so we have two kube configs, one for DSM and one for the infrastructure admin. So they both show the same set of resources, but the permissions are different. So as an infrastructure admin, you can do certain tasks. As a DSM admin, you can do certain tasks. And this is what a YAML manifest would look like. So if you had an end user or developer who wanted to use the API server to build a database, this is essentially what they would be creating. They would populate something like this. As I said, it's all the same kind of stuff we've seen a few times now in the DSM UI as well as in ARIA automation, but now it's in a text file called a YAML manifest. So we're going to create a new database by just sending that YAML manifest contents over to our API server. It says it's created. Let's query it and see what happens. Yeah, if I specify the kube config, my deliberate mistake. Just make sure everybody is watching. So there we go. So the original database is still there. This new one is currently in progress. And there we go. Basically what we were able to reference from the kubectl, we can see exactly the same thing in the UI. So we can see the name, we can see the version, we can see the database owner, a standalone database. It's not replicated, which is exactly what we put in there. It does have a monitor component that's part of the same VM. You can see it. It's a Postgres specific thing. We don't necessarily need to get into it. But hopefully what you've now just seen is that we can consume databases through both UI with the click of a button and through our API as well. So whatever way your end users are more comfortable with or whatever their preference is, you can tackle both. So let's summarize. Like I said, the whole objective of this at the outset was really to reduce friction between the different IT teams, friction between the end users having to wait for their database admins to provision databases for them, but also reduce friction with the vSphere team where they're not suddenly seeing these databases or VMs popping up, consuming resources and not having any clue of what are these things that keep popping up and going away. So we're hopefully, that's the point I got across with DSM. We are reducing the friction between these different teams. You can still go with your ticket-based approach and have a centralized data admin team who are responsible for provisioning databases, but now they can provision databases very quickly, very easily, but they also get the automated backup features, they get the automated lifecycle management features. And the VI admins not only have the visibility into all of these different VMs that now might be popping up to host databases and data services, but they know that they're guardrailed within the compute, within the storage, within the network, and that they can't, they're not going to run into these issues where, maybe a misconfigured script has built 1,000 databases by mistake and filled up all the compute on an ESXi host or consumed a whole data store or whatever the case may be. So considering we have, I think, a few minutes left, I'm just going to leave you with this slide and then we might tackle some of the Q&A. So this QR code here, if you're interested in getting access and maybe some assistance as well, because it's still early days for us, we're in a position that we can give some white glove assistance to certain customers to help them through a POC. So yeah, we do have an advanced services team who can help you with that kind of thing as well. I suppose the last thing to leave you with, hands-on lab. There is a hands-on lab currently, but we are updating it for Explore as well. So if you want to check out the hands-on lab, it's number 2407 today. But also if you're heading to Explore in Vegas, we'll have an updated Data Services Manager hands-on lab as well. So go and check that out too. So without further ado, I'll open the floor. Do we have any outstanding questions?
Yeah, we got a couple here. First off is, of course, the DSM question. If DSM is part of VMware Cloud Foundation.
Yes, it is. So if you
And
have VCF, you're entitled to DSM. Absolutely.
awesome. And then is there a way for people to try that? And I suppose that probably the best solution with that is going to be the hands-on lab, unless there's another avenue.
Yeah, so definitely the hands-on lab would be one approach, but the product is available for download. So if you go onto your support portal, you will see that there's a VMware Data Services Manager section, and you can just pop in there and download it and try it out as well. As I said, it's
Super
just
cool.
a single appliance. Yeah, it's just a single appliance, but you install it through the plugin mechanism in the vSphere client. So
All right.
quite straightforward. Quite straightforward.
Mhm. And that kind of leads into our next one, which is how can I integrate this with the service catalog I use already?
Okay, so that probably need a bit more information, but it's the service catalog that's within area automation. I'm going to make
Mhm.
an assumption. And so,
Mhm.
yeah, so that customer resource just adds into your service catalog. So the config.json that I showed you, where you filled in the information about DSM and area automation, you can just populate that, and that object will appear in your
Mhm.
catalog in area automation. If I'm not answering the question correctly, please reach out to me directly. It's just cormac.hogan@broadcom.com, and we can get more information. I'm just assuming that it's an area automation question, but
Yeah,
I may not
not a
be
problem.
assuming that correctly. Yeah,
And I think that was just about it. There was a couple other questions that got answered in line, so those were taken care of. So we'll be sure to get an output
super,
of those out there for you. So with that, I think we're just about there.
awesome,
Alrighty,
awesome.
sir. Well,
Well,
thank you so much for coming in today.
yeah, thank you, Anders, and thank you to everybody who's attended the presentation. I
Mhm.
hope you found it useful.
Awesome. And thanks to our QA helpers who are online helping with the QA and managing some of the chat. And just as a reminder, we will be out for the next couple of weeks for VMware Explore, but we will be returning the first week of September. So recordings will be up on YouTube if you're following the channel, so you can catch up with us there, watch previous iterations of this broadcast, and all of our archives are there, so you can share with anybody who might not have been able to make it today. So thanks again, folks, and we'll talk to you all soon.